Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you define the general behavior that a whole category of objects can have. So when you create individual objects from the class, each object is automatically equipped with general behavior. So you can then give each object whatever unique traits you desire. And you will be amazed how well real-world situations can be modeled with object-oriented programming. So making an object from a class is called instantiation. And you work with instances of a class. So in this section, you will write classes and create instances of these classes, and you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. So you will also write classes that extend the functionality of existing classes. So similar classes can share common functionality, and you can do more with less code. So you will store your classes in modules and import classes written by other programmings into your program files. So learning about object-oriented programming will help you see the world as a programmer or coder does. So it will help you understand your programs, and not just what's happening line by line, code by code, but also bigger window here and bigger concepts behind it. So knowing the logic behind classes or object-oriented programming will trait you think logically, so you can write programs that effectively address almost any problem you encounter. So classes also make life easier for you and other programmers, and you will work with as you take increasingly complex challenges. So when you and other programs write code or programs based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to the people you work with, allowing everyone to accomplish more. So you can model almost anything using classes. Now we will write a simple class, which here we will create a car. That represents car, but not one car in particular, but any car. So what do we know about most cars? Well, they all have car makers, they all have models and years, and we also know that the most cars are automatic or manual, right? So use three pieces of information, which is car, model, make, and year, and use behaviors, which is automatic and manuals, will go in our car class because they are common to most cars. So this class will tell Python to make a new object representing a car. After our class is written, we will use it to make individual instances, so each of which represents one specific class. So now we're going to create a car class. So each instance created from the car class will store a car model and make. This will be the same variable and year, and we will give each car the ability to drive and stop. Or actually, we can also add automatic and manual, but yeah, we will decide that here. So class car here, class car, and here we will add just a simple program that that written for cars, and here we will use init, but you will learn what init is. So init here, and we will add self name or car model make and model, car make and model, and after that we will enter the year, and after that we will, here we are initializing initialize make and model year And let's actually add the gearbox also, right? Gearbox. So here we will add gearbox. So gearbox can also be automatic, manual. CVT is a different kind of gearbox, but it's still gearbox, right? But in this case, we will add just automatic and manual gearboxes in our cars. So we will also define a new, but inside the car class. So here we have this indentation. So here we will define inside this car class the drive. Here we will use self, and that you will understand what these keywords are. And print if here self dot name, oops, inside the braces here, self dot name or self dot make and model and is now driving. And also we will use make and model. Also we will add year, self dot year, and also we will add self dot gearbox. Gearbox is now driving, right? So for example, BMW 2015, BMW 528 E here, year 2015, and gearbox is automatic, is now driving, right? And after that we will add another here, another function, which is going to be, let's stop here, right? Let's stop driving, and here we will also add self. So here we will print here with format, and we will copy this. Actually, let's, instead of copying this, let's write this right now here. Self dot car make and model, make and model, year, and so gearbox is stopped. That's it. So now I will explain this one by one. So here, oh sorry, it will not return anything because we didn't use this class, we just defined it, we are not using that yet. But here let's first explain it, and then let's create examples from it. So here there's a lot of notice here, but don't worry. So you will see the structure through this course, through this section, and have lots of time to get used to it. So first we define a class called, here we define, oh sorry, so we define a class, sorry, here, let me actually use my marker. So here we define a class called car. So by convention, capitalized names refer to classes in Python. So there are no parentheses in the class definition here because we are creating this class from scratch. So we then write the doc string. So this doc string here describing here what class does. So actually let me write this here, doc string. This is a doc string here, and so here we are here seeing init method. So here, oops, actually here, so a function that's part of a class is method. Everything you learned about function applies to methods as well. The only practical difference from now is the way we call methods. So the init method here, the init method you are seeing here, actually let me use different color. this init method here, let's make it bigger so you can see the characters. So this init method here is special method that Python runs automatically whenever we create a new instance based on the car class. So this method has two leading underscores, and here 2 underscores and 2 trailing underscores. A convention that's helped prevent Python's default method names from conflicting with your method names. So make sure to use the 2 underscores on each side of init. So if you just use one each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. So here we define init method to have 3 parameters. No, actually 1, 2, 3, 4 parameters. The self, actually let me, yes, here, the self, make and model, year, and gearbox, right? So the self parameter is required in the method definition, and it must come first before the other parameters here. So this should be first, as I said. So it must be included in the definition because Python calls this method later to create instance of car, and the method call will automatically pass the self argument, and every method call associated with an instance automatically passes self, which is a reference to the instance itself. So it gives the individual instance access to the attributes and methods in the class. So when we make an instance of car, Python will call this init here method from the car class, and we will pass car a make and model, a year, and a gearbox as arguments, and self here is passed automatically, so we don't need to pass it. So whenever we want to make an instance from our car class, we will provide values for only the last parameters, which is make and model, year, and gearbox, and not self here. So the 2 variables are defined in the body of the init method, each have the prefix self here, self, and self, actually not this, here, self and self, right? So any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. So the line self name here, the line self make and model here, actually let me write another code here. The self make and model, oops, actually let me we will write this here, self make and model equals make and model. Here we will get an error here, self make and model. We will do it inside this. So here, oops, actually let me delete this here. So here self, the line self make and model equals make and model takes the value associated with the parameter make and model and assigns to it the variable make and model, which is then attached to the instance being created. So the same process happens with the self, for example, year or gearbox equals gearbox, and the variables that are accessible through instances like this are called attributes. So the car class has 2 other methods, which is drive and stop driving. Because these methods doesn't need additional information to run, we just define them to have one parameter, which is self. So the instances we create later will have access to these methods. In other words, they will be able to drive and stop here. And for now, the drive and stop don't do much, and they simply print a message saying that our car model, year, gearbox is stopped, or in drive here, make and model, year, gearbox is now driving. So but the concepts can be extended to realistic situations. So you can for example do it for a computer game or real world applications, or so on, which you will learn in next lectures. Think of a class as a set of instructions for how to make an instance. So the car class is a set of instructions that tells Python how to make individual instances representing specific cars. So let's make an instance representing a specific car here. So under the here we will use without indentation here. We will use my BMW here and car here. Of course, BMW is car. And here we will add here. Actually, you can use Ctrl and P here. CTRL here and P to see the information or the functions you can provide. But here we are also seeing this, which is we need to provide the make and model. Actually, let me here in the first step we need to provide make and model, year and gearbox. Here this is the same. So as you learned in previous lecture, we don't need to provide self as a parameter, so we will ignore it. Here make, first we are putting make and model, year and gearbox. So in make and model we will write a string, of course. So BMW 325 E here, and the year is gonna be 2002, and the gearbox is gonna be automatic. So that's it. And after that we will print the instance, of which you here you will learn all of these codes, what these codes do and why are they doing this. So my cars make and model is here, and here we're my BMW dot make and model, and here print again format my cars car years of production, year of production is the my BMW dot year, is it right? We have make and model, we have year. Yes, we got an actually, let's try this. Yes, we got an error here. Car object is now attribute year. So first we are entering BMW 310. Actually, instead we need to here my BMW dot year. We have drive, stop driving, we have make and model. Of course we need to make it like this, self we forgot this here, self year here, self gearbox. Yeah, gearbox is gearbox. That's it. And here we will get here, and as you can see, is gearbox and year is appeared here. So first we're gonna print year. Let's run this here, and after that we will also print the gearbox type. Print my car's gearbox type is, and here we will enter my BMW dot gearbox here. That's it. Now I will explain all of these codes, what these do, and here as you can see we have successful output here. So now we will explain all of this here. So the car class we are using here is the one we just wrote in the previous lecture. So here we tell Python to create a car whose name, my car here, my BMW here, whose car make and model is BMW 325E, and the car year of production is 2002, and the car gearbox is automatic. So when Python reads this line, it calls the init method in our car class with arguments, the make and model, year, and gearbox. In this case, it's, as I said, BMW 325e 2002, and automatic as gearbox here. And now then the init method creates instances representing this particular car and sets the name, sets the make and model, year, and other attributes using the values we provided. So we assign that instance to the variable my BMW. The naming convention is helpful here, so we can usually assume that capitalized names like cars refer to class, and lowercase like my BMW refers to a single instance created from a class. To access the attributes of an instance, you use dot notation. So we access the value of my BMW's attribute using dot by writing BMW year or BMW make and model, BMW gearbox. So we use dot to access the value of my BMW's attributes named make and model, year, gearbox. So this is the instance and this is the attributes. So dot notation is used often in Python. So this syntax demonstrates how Python finds an attribute's value. So here Python looks at the instance my car and then finds the attribute make and model with my BMW, right? So this is the same attribute referred as the self, make, and model in the class car. So we use the same approach to work with the attribute year or gearbox. So the output here looks exactly like this. Firstly, my car's make and model is BMW, so we use my BMW dot attribute make and model. We use my BMW dot year, my BMW dot gearbox. So we can also call methods. So after we create an instance from the class car, we can use dot notation to call any method defined in car. So let's make our car to drive or stop driving, right? So after this, after print methods, or you can also add there or there as well. So if you add here my BMW, here we not defined my BMW, so you add to, as the syntax, you need to use this variable after the variable created. So here my BMW is not created, that's why we are getting an error. So after BMW created, we can add, for example, my BMW dot drive, and here, as you can see here, we got nothing. So no, actually here the BMW 325e 2002 automatic is not driving, and after that we are printing a car make and model. So sorry, let's delete it. And after printing the specifications and information about our car, we can call the drive and stop driving methods, right? So my BMW dot drive, my BMW dot stop driving, my BMW dot drive, and my BMW dot stop driving. And actually what BMWs do good is drifting. So let's actually use add another method here, which is drifting. Start drifting here, drifting, and we use self here, and after that we will copy this. Actually, we will use print f here. So now we will use self dot make and model and self dot year. After that we will also add self gearbox is drifting here. Here, let's add more D here. That's it. And after that we are driving now, and after that we're gonna start drifting. So start drifting, and as you can see here, BMW 325 2002 automatic is drifting here. So this syntax is quite useful when attributes and methods have been given appropriately descriptive names like the start drifting, stop driving, and drive. So we can also create a multiple instances. So you can create as many instances from a class as you need. So let's create the second car here. Let's actually use the my Bugatti. No, it's too much. So let's my Honda here, Honda, and we will use my Honda equals here. So now we will again use the car, or actually we can also use the create a Honda here. It's here. So BMW, or it's Honda, right? So Honda Civic here, it's gonna be 2015. Let's actually use strings. We can also use integers, but yeah, string is more clear. So, and let's make it manual, right? More here. That's it. And here after that, we can also use my Honda here, my Honda that, for example, we can also do this. Instead we can also change my BMW to my Honda, so we will get same result but different values. Honda and my Honda, and after that we can also my Honda that, let's make it drive. We can also drive Honda. We can do the same things that we did with BMW, like my Honda make my Honda drift, start drifting. That's it. We can also add Honda inside after the BMW, because Honda is defined here and we are adding our code here. Now let's run this, and here this is the output successfully. This is a lot of output, right? So this is the output here. So in this example we create a car named my Honda, and here each car here, my BMW and my Honda, is separate instance with its own set of attributes capable of the same set of functions. So here my car make and model is BMW 325e. For example, my car make and model is Honda Civic here, and my car's years of production is 2015, and my car's years of production is 2002. So this is how we work with the classes and their instances, and see you in the next lecture. Thank you for watching.